I am delighted to welcome you to the first day of our 8 weeks together as you join me on this adventure to master AI and LLM engineering. Now look, it's customary in these things to start with me giving an introduction about myself, tell you about the course, tell you what you'll accomplish over 8 weeks, etc., etc., etc. But no, this isn't that kind of course. It's not what I'm going to do. We have plenty of time to get back to that later. What we're going to do now is get right into the thick of it and get you set up and using an LLM on your computer right away for a useful purpose. So without further ado, go on to the next video and I'll get you set up. So we're now going to run a large language model directly on your box using a platform called Ollama, which lets you run C++ code version of LLMs compiled directly on your machine. I'm going to start by showing you on Windows and then we'll flip over to Mac. So to start with Ollama, you bring up your favorite browser. Let's go Microsoft Edge, and you can simply go to ollama.com or just search Ollama, O-L-L-A-M-A. It's O followed by Llama. And the first hit here in the search results will be ollama.com, and here it is. It's called Ollama because it was initially built around a model that's called Llama, which is the open source model from Meta, which really stole the show a couple of years ago when it first came out. So downloading is as simple as pressing the download button. And once you press the download button, you press download for Windows, and it will start to download the Windows version. And if I look here at my downloads, I will see that it has downloaded. There's a setup.exe. If I press the open file button, it will prompt me. Oh, it's still downloading again. I just ran this. It will prompt me to install it locally, which I will do. As soon as it's installed locally, you then go to the start menu, and you're probably familiar with this, but you bring up a PowerShell by typing power in here. And as soon as you do, it prompts you and you press open, and up comes a PowerShell, which is where we are going right now to run a large language model minutes into this course. And the way we do it is we simply type, once that install is completed and you pressed OK, you can just simply say Ollama, O-L-L-A-M-A, run, and now you put the name of the model next. And the name of the model we're going to use is going to be Llama 3.2, which is one of the very newest models. And so here it goes, and it's run. It's happening right now. That blinking cursor means that we have a large language model running on this computer. It might take a bit longer for you the first time. It has to download the 2 billion parameters associated with Llama, and depending on your internet connection, that might take a little bit, but you'll get a progress bar that will show you what's going on. So what we're now going to do is try and talk to this LLM, and we're going to try and do something useful with a free LLM. And here's what we'll do. I'm actually trying to learn Spanish at the moment, and I can tell you that my grasp of the Spanish language is distinctly less inferior to my grasp of LLMs. The app that I'm using to try and teach me has a service where you can pay to chat with an AI tutor. Now, I don't want to pay for that because I know I can run an open source model and do it for free. So right now, we're going to build ourselves a Spanish tutor, which will teach me Spanish, all open source without paying a penny. So I'm going to say, I am trying to learn Spanish. I am a complete beginner. Please chat with me in basic Spanish to teach me. And so that is the prompt that we will start with. And let's see what happens. It's thinking, hola, and welcome to our conversation in Spanish. To start, let's begin with some basic greetings. ¿Cómo estás? So you can see that it's giving me a very good starting prompt. It's giving me some examples. It understands where I'm coming from. And I can now say something like, I won't put an accent on. Oh, there's a small mistake. Okay, there we go. It's corrected me. I think it's the accent that I missed and maybe the question mark as well. So you get the idea. We've actually just built something which has commercial value because indeed this is sold at a price immediately for free on our boxes using an open source LLM. That is LLMs in action from the get-go. And now for Mac people, let's flip over to a Mac. And now over to my Mac people, and I have news for you. It's exactly the same thing. you go to a favorite browser, you go to ollama.com, you'll see the same screen, you press download and then download for Mac OS. It will, of course, download it locally. You will then run the installer and it will install it. You then bring up a terminal window, and you bring up a terminal window by going to Applications and Utilities and then Terminal. And when you bring up that terminal window, as it comes up here, you type the same instruction, Ollama, run, and now the name of the model, which in our case is Llama 3.2, the very latest small model from Meta, and it will then come up. It will probably take a minute or two because it will need to download the 2 billion parameters associated with 3.2, but then it will be running just like this. And now again, we can try and put it to good use. We can ask it, this time we'll use a different language, why not? Let's say, I am trying to learn French. I am a complete beginner. Please have a conversation with me to teach me French. And let's see how it does. The first thing you'll notice is that it's a lot faster, and that's because I'm actually running on a Mac with an M1 chip, and what we were seeing earlier was an emulation of a PC. So of course this is a bit faster. Your computer may be somewhere in between those two depending on your architecture. So off it's gone with the start, and you can see that it's done a fab job. It's clearly given a bunch of different options. It's explained itself. It's super impressive. Let's say, bonjour, ça va. I'm not actually answering his question, but there we go. You get the idea. And the point I wanted to make again is that this is in fact a paid commercial product on an app that I'm using. And here we have it. We have built effectively a commercial project for free using open source in a matter of minutes, just immediately unleashing the power of an LLM on your computer. So I now have an exercise for you right away. I'd like you to, of course, do this, install it, make sure that it works. If you have any problems whatsoever, then you can always contact me at any point. Feel free to message me or send me an email or LinkedIn with me and ask for help. But hopefully this is a really easy install. It will have you up and running. Do this. Have a quick experiment with a language, pick a language, maybe one you don't know, and try it out. And then the next thing to try is I'd like you to experiment with different models. So if we go back to the Ollama page, you'll see that there's a model heading up here. And for both PC and Mac people, it's the same thing. You can see some different models and read about the story behind them. Llama 3.2 from Meta, Jammer from Google, which is its open source low parameter version, Qwen, which is a powerhouse of a model from Alibaba Cloud, which is less well known, but it is one of the strongest. You can click on a model and you will then see the different versions of it. And over here is the way that you can run it. You can simply press that button there to copy it to the clipboard and then paste it into your PowerShell or your terminal. And these are the various different versions of it. And you can just go back to models, browse through them, experiment. Phi 3.5 from Microsoft, also a very powerful model. And you can read more about them, experiment with them. And I would like to ask you to try this out for a new language, try exploring, maybe try and learn something completely different, and use different models and see if you can figure out which models are best for you. As you pick some of the larger models, they may be slower on your computer. So find out which models perform the best and give you the best results. That's your exercise. And then I will see you for the next time when we will then do things like introductions and course and all that stuff. See you then. So I hope you've just enjoyed yourself experimenting with different LLMs locally on your box using the power of Ollama. You've probably had similar experience to me, which is I certainly found that Qwen 2.5 is perhaps the most powerful model when it comes to grasp of different languages. Some of the other models are better, I think, at explaining. So I'd be very interested to hear your observations. Please do post them with the course or message me direct. I'd love to hear what you've discovered. And this kind of experimenting with different models and finding the one that works best for your problem, that is a critical skill for an LLM engineer. So this was valuable time spent. All right, let's talk about the next 8 weeks. So I am looking to take you from where you are today, over on the left, to being a master of LLM engineering in 8 weeks' time. And this is how we'll do it. We'll start this week by looking at models at the frontier of what's possible today, which people call frontier models. Things like GPT-4o, O1 Preview, and Claude 3.5, and a number of other pioneering models that are closed source and are able to achieve amazing things. And we'll do that through the web user interface like ChatGPT, and also then through the APIs. And we're going to build a commercial project, something immediately that will be useful, and there'll be an interesting commercial exercise for you as well. Then next week, we will slap a user interface on top of it using a platform which I love, which is called Gradio, and we will have good fun with it, and you'll see that I love it. I go on about it a bit, but it's so easy to use, and it's so easy for people like me who are terrible at front end to build a nice, sharp user interface very quickly indeed. We'll do it to solve a classic Gen AI use case, which is the building an AI assistant, a chatbot, but we'll do so in a way that has audio and pictures, so it's multimodal, and it will be able to use tools, which means that it's able to call out to code running on your computer, which sounds kind of spooky, but it's going to make sense when we do it. So that is all week 2. In week 3, we turn to open source and we use the ubiquitous Hugging Face platform, which is used by data scientists, LLM engineers across the board, and we'll use it to build we'll use the simple API in Hugging Face called the Pipelines API, and then we'll use the more advanced API, and we'll explore things like tokenizers and models in Hugging Face. In week 4, we're going to talk about something which is a particularly thorny issue in the world of AI, which is there are so many models to choose from. How do you go about selecting what is the right model for the task you have at hand? So we'll work on things like benchmarks and leaderboards and figure out how do you go about that decision path. And then we're going to take on a particularly different kind of commercial problem about generating code. We're going to build an application which is able to rewrite Python code as C++, high performance C++ code. And we're going to then try it out with a bunch of closed source and open source models. And one of them will be the winner. The one that's the winner is going to take our test Python code. It's going to rewrite it. And the new code is going to run 60,000 times faster, which is shocking. And you will see that yourself. And then there'll be some exercises for you to build other kinds of code generation tools. In week 5, we will turn to one of the topics that is super hot at the moment, which is RAG, Retrieval Augmented Generation, using data stores of information to add expertise to your LLM. We'll be building our own RAG pipeline for answering questions that pertain to an organization. And then there'll be a difficult commercial challenge for you, an exercise in which you apply this to your own information. And I'm really excited to see what people make of this and to see some of your projects of rebuilding a RAG pipeline for yourself. In week 6, we begin our 3-week flagship project for this course. Week 6, we will set up the business problem. We'll do a lot of work on data, and we're then going to create some traditional machine learning models, which is very important to do to build a baseline. And then we'll try models at the frontier, and we'll fine tune models at the frontier as well to do as well as we possibly can with this business problem. In week 7, we'll apply it to open source. We're going to take open source models, and they're initially going to perform terribly, and we're going to make it our mission to improve those open source models by fine-tuning until at least we can compete with GPT-4o, the model at the frontier. And I'm not going to tell you what happens, but I will tell you that I believe that the results will astonish you. I will tell you that. So it is very much worth hanging on and seeing what happens in week 7. But then it all comes together in the finale in week 8, which is a fitting conclusion to the 8 weeks. We are going to build a fully autonomous agentic AI solution, which will have 7 agents collaborating to solve a real commercial problem. And at the end, not only will it be doing something where it scans the internet for various things, but will end up sending you push notifications with some of its discoveries. So it's going to be really fabulous. It's going to have a terrific result at the end of it. It will be a good way to be a culmination of everything that you've learned each week, building on top of it of the prior week, and resulting in true commercial projects that you'll be able to put into action in your day job right away. The mantra of this course is that the best way to learn is by doing, and we will be doing stuff together throughout. There will be 8 commercial projects, which will be applying what you're learning to real business problems, and there'll be exercises for you to do the same thing. And I'm hoping that you'll be able to set up GitHub and be able to make your own versions and push them and send me a PR, a pull request, and I'll be able to merge in your code so that other people can see your solutions too. But you'll be able to add this to your GitHub and be able to show yourself that you are building projects to solve real-world commercial problems. One of our projects I mentioned is going to be a chatbot assistant. We're going to build one for an airline. It's going to be able to do things like use tools to look up the price of tickets. It's going to make audio, and it's going to show pictures like this beautiful pop art version of London showing here on the right as you interact with the chatbot assistant. We're also going to be building RAG pipelines, putting vectors of information in a vector data store that you'll have running, and we'll be able to look at things like visualizations of the vectors, mess around with them in 3D space, look into them to understand how different kinds of information get placed in different locations in vector space and why that is fundamental to RAG, retrieval augmented generation. And then, as I say, the big moment in the project will be in week 8, when we will build an agentic AI solution that will bring together everything that you've learned about through the 8 weeks for something which will solve a business problem. And I'll be able to give you some examples of how you can then apply that to solving other business problems that you might face in the future or that you might have today. And you'll be able to watch as agents collaborate. You'll see the memory of the agents and see what's going on in our agent world. A lot to look forward to. I'll just take a quick moment to introduce myself to convince you that I am actually qualified to be taking you on this 8-week journey. So my name is Ed Donner. I've got about 20 years of experience in software engineering, data science, and tech leadership. Most of my career at JP Morgan, where at the end I ran engineering teams of about 300 people. I started out in London, where I'm from. I then moved to Tokyo for a bit and ended up in New York City, where I live now. After JP Morgan, I founded a couple of AI startups. My first startup was acquired a couple of years ago. And in fact, that picture on the bottom right shows the moment when it was announced on a Times Square billboard. That was a particularly magical moment for me. But I don't just show you that photo to brag about my Times Square moment, but also because, curiously, I actually live very near Times Square. It's an unusual place to live. Because it's such a sort of tourist place to be. But if you see these 2 red arrows and you imagine where they join up, that's basically where I live. And that's where I am right now. And so if you can imagine, if I wave at you right now, if this were somehow a real-time photo, you'd have a little me waving at you from round about where those red lines meet. Okay, and the final thing to mention, the picture in the middle at the bottom shows me flying or in front of a plane. You might be thinking that's me saying, this is my big passion, my hobby, I fly planes. But in fact, that's not what I was going to say. It turns out that whilst I'm very proficient and highly skilled in the field of LLMs, that does not translate in any way to my hand-eye coordination, which is terrible on almost any front, including flying planes, where I have tried and am very shaky, to say the least. So if it turns out that you find yourself in a plane and you look at the cockpit and you see that I am the person there on the stick, I suggest you look quickly for the nearest parachute. But if it comes to you needing to go on an 8-week course to build up commercial expertise in how to be an LLM engineer, then you've come to the right place. All right, without further ado, let's get to the course. So we're now going to start week 1 of the course, when we are going to be looking at exploring frontier models at the forefront of what's possible. In this first day, we're going to set up an environment and then build your first LLM solution. We're then going to talk about how to be positioned for success in the next few weeks. We're then going to compare models at the very frontier of what's possible, some that you know well and some I think will be new to you. We're then going to talk about transformers, which is the architecture at the heart of the different models that we use in this course, almost all of the models. And then finally, we'll end with a juicy commercial project that you'll be able to use, and I'll have an exercise for you to make it your own, apply it to different business areas, something that maybe you can use in your day job immediately. Maybe you'll be able to use it as a project that you can have as an example project for yourself. So we're now going to get hopefully some satisfying instant results for you. We already used Ollama to do some fun things on your computer already, but now we're going to take it a notch higher by calling out to APIs directly. But first, the necessary first step is to set up your environment. Create a full spec data science environment that will have the sufficient horsepower to take you through the entire 8-week program we have ahead. And there's quite a lot of stuff that we're going to need to install to make sure we're at that point. And I guess I should mention that sometimes this experience can be a bit frustrating. Most of the time it goes really smoothly and everything just fits in place and it's 5 minutes and you're done. But sometimes some people hit speed bumps for whatever reason because of something about the system or some other new effect, and it can be a bit frustrating. But I am here to take you through it step by step and make sure it's successful for you so that this will go smoothly. It'll be behind you in no time and we'll be on to actual projects and we'll never have to worry about environment setup again for the next 8 weeks. So creating the full spec data science environment. It ain't as easy as I wish it were. There is some stuff to do, but we'll get through it fast. First of all, we'll clone the repo. For people who are familiar with Git, that's easy, but I will make sure I walk you through it in case this is a new thing. Then we will go through the README instructions to set up the environment. Now, I recommend that we use something called Anaconda that some of you may have already used. Anaconda, it's a high-powered thing, and it's quite heavyweight. It creates an entire environment for you, a dedicated, isolated environment on your computer for this course. And it does so in a way that guarantees high compatibility between what you're doing on your computer and what I do on mine and everyone else on this course. So it's very good at that. But it is quite heavyweight. It involves downloading a lot from the internet and installs a lot because it builds everything from the ground up. If it causes you problems, there's an alternative. We can use a simpler approach, the standard Python virtual environment approach with pip, and I've got instructions for that too. It's quicker, it's simpler, and it's just not as guaranteed to be compatible as Anaconda. So I prefer we try Anaconda if possible. It does work most of the time. Any problems at all, the Python virtual environment is your fallback. We then need to set up an OpenAI key, and I'll talk more about that. I'll talk about API costs and what to do if that's a problem for you. We'll go through that at the time. We have to create something called a .env file, which has your private keys in it. And it's going to be important that that file is called exactly .env, as we'll see. I will explain, but it can't be called keys.env or .env.txt. It has to be called exactly .env. And then finally, we activate your environment and we run Jupyter Lab to start the program. So, as I say, most of the time, all of this will go great. Most people report that everything goes through fine. But if it doesn't, then there are some secret weapons at your disposal to make sure that it does. The first of them is that I put a troubleshooting notebook that I will show you in the GitHub repo, which will take you step by step through diagnosing problems, running some code that will figure out what's wrong, and then fixing each problem in turn. So that is there. The second resource you have is a kind of surprising one. ChatGPT and Claude, they are spooky in how good they are. If you say a problem and paste like a stack trace in there, they are very impressive at giving quite nuanced answers about what you need to do. I've been caught off guard by the times I've run into an infrastructure problem and I thought this is way too much. I can't even get the answer on Stack Overflow. But I've been rescued by Claude. I think Claude is the stronger of the two, but both of them give good answers. So it's worth realizing that you can often just fix the problem by pasting it in there. It's worth giving it a shot. But if those two fail, or even if you'd just rather go straight to this third option, the third option is there, and the third option is to contact me. I am standing by to help you. That is my job. So please reach out. You can reach out to me by messaging me on the platform. You can email me. My email address is in the README, and you can also LinkedIn with me. I love getting LinkedIn connections, by the way. So LinkedIn with me for sure, and message me there too. And you'll find that I'm very responsive. Typically, if I'm not sleeping or traveling, then you'll see from my other answers that I get back very quickly. and I see it as my job to fix it and to get you up and running. And I have never failed yet. I have always, I think, 5,000 people through, and everyone has a running environment, as will you. So if you do hit any speed bumps at all, you can go with these other two options, but you can come straight to me. I will fix it. I will find what's going on. We will have you up and running quickly. All right, with that, let me now take you on a walkthrough of what it takes to set up your environment. In this video, we're going to set up a full data science environment for Mac users. In the next video, we'll do PC users. So if you're a PC person, please skip to the next. You can listen in here if you wish, but otherwise I will see you next time. Okay, so my Mac people. Now, I'm a Mac person myself. I've always owned Macs. So you are my home crowd. You are definitely my favorites. And it's not like I'm going to say the same thing to the other guys. Well, maybe I am. Anyways, this is looking right now in a Chrome browser at the repo LLM Engineering in GitHub. And this link should hopefully be plastered all over the place, including in the lecture notes for this lecture. But please come here and look at the GitHub repo to see the code that we have. What you'll also see if you scroll down is the contents of the README file, which is where I have laid out what needs to be done to set up your environment. And I hope that I've done a decent job here of laying things out step by step and being clear on what action to take if anything is to go wrong. So hopefully it's good, but if you have any corrections to make to it, as some people already have, for which I'm very grateful, please do let me know and I'll do that. Okay. But for now, what you're going to do is press this green button here, code, and then you can pick either of these two, but you're going to pick this copy button here, which is going to copy the URL that identifies this repo into the clipboard. And that is done. All right, we're now going to bring up a terminal window where we're going to go next. Now, some of this you can do using the Max Finder windows if you prefer that, but I'm more comfortable in terminals, and I imagine many of you are too. So I'm now in my home directory. Many of you will have a projects directory set up, which is where you manage your projects. At the moment, I don't have one set up. If I do cd projects, there's nothing there. So I'm going to make a directory, projects, and go into it. Here we go. And then the next thing I'm going to do when I'm inside the projects folder is I'm going to type git clone. I want to clone a repo and paste in the name of the repo right there. And when I press enter, it does its thing, and I now have locally an LLM engineering folder. I'm going to go into it, and there is all of our code. It's worth pointing out that where we are right now in the LLM engineering folder is what people sometimes call being in the project root directory. That's the name for where we are right now for this project, the project root directory, LLM engineering. All right, so the next thing to do is for us to look at installing Anaconda if you haven't installed it before. And the README has a direct link to the installation page at anaconda.com, which will allow you to set it up for Mac OS. There's a simple set of screens that will go through and configure it. I'm not going to do it because I've already done it for me, but it is very clearly step by step, as you will see it here. And before you know it, you'll have Anaconda on your box. When you have Anaconda on your box, back to the terminal window. Here we are. We simply call a command that tells Anaconda to do everything, to build a whole data science environment for us. And that command is Conda, env for environment, create, -f, which means we're going to specify a file which has the full description of the environment. And that name of that file is environment.yaml, which you can see right here. That is the file that defines this environment. And when you've done that, you press enter. Now, what's going to happen now is that Anaconda is going to connect to its server, find out everything that we need to do, and it does what is called solving environment, which means it figures out what versions of each of the different packages we need are going to be the right versions that we need to have a fully compatible, full spec environment. And what you saw it just doing there with all of that stuff going on was it feverishly downloading the various packages and building them. Now that might take a fair bit longer for you because it's fast for me because I've already done it and it's cached locally. The first time it needs to download it. For me, I have a pretty good internet connection and it took about 5 minutes the first time I did this. Someone reported that it was taking more than 20 minutes for them, which is, of course, a lot of time to wait. So if it's taking that long, then that might be, if you have a slower internet connection, that might be expected. But if it takes much longer than 20 minutes and you have a good internet connection, then something's not working with Anaconda, and I would cancel it with Command C, and instead we'll use the other approach, the virtual environment approach instead. So right now, Anaconda is busy doing what it calls executing the transaction, which is essentially after it's figured out what versions of what we need, it's building that whole environment. And then at the end, for those that know about this, there are also some packages that I pip install because they don't yet have Conda versions. So there are some packages that get pip installed at the end of it. But when you see installing pip install, you are near the very end. And it's done. So I didn't lie. It doesn't need to take a long amount of time. It's pretty fast. When all of that is done, we need to activate our new environment, which means we need to say we want that to be the live environment that's currently being used. If you look at my cursor right now, you'll see the word base is to the left here. And that means that we're not currently running in an Anaconda environment right at the moment. In order to use our LLM environment, the name of the environment is LLMs, and we're going to type Conda activate LLMs. And that is all it takes to tell Anaconda we want to be running in this environment with the same version of Python, the same version of all of these packages. That means that we are completely consistent. That happened immediately, and you'll see that LLMs is now written on the left. And if you're seeing that, that is your clue that it's worked and that you are now running the right version of Anaconda. And as a final step here, I type in this command, Jupyter Lab. And Jupyter Lab is the command that says I want to launch this data science environment called Jupyter Lab, which allows me to work very interactively with code. And when I run that, it thinks for hopefully just a moment while it considers the task at hand, and then it will launch Jupyter Lab in a new screen, and what you will probably see is something a bit like this. All right, with that, I'm now going to pause for you guys. I'm going to record a video for the PC users, and I'll meet you back in 2 videos time. See you there. Well, hi there. This is time for PC people to get set up. So all you Mac people out there, you don't need to be watching this one. And now's the time when I tell you guys that I told the Mac people that they were my favorite people because I'm a Mac user myself. But, you know, I am a Mac user, but I'll have you know that I started out in PCs. I, in fact, worked for IBM for a few years. So really, in my heart of hearts, I'm from IBM, from PC blood. So you guys are really my people, no matter what I said to the other people. Anyways, let's get you set up with a PC to use the environment that we need for this entire course. So we start by going to the repository, my repository for this class, LLM Engineering, which is at github.com/my name/LLM Engineering. This link should be all over the place in the course and in the notes for the course and resources and so on. And when you go there, you see this repository on GitHub, and if you scroll down, you get to see the README file that I've written with setup instructions. And I hope I've done a decent job in laying out all of the steps required to set up your environment. And if you prefer to follow instructions that way, then do it that way rather than watching the video. And hopefully I've done it well. And if you find a problem with them, please let me know so I can update them for everybody else. Anyway, if you do go through these instructions, what you'll find is that the first thing it says is that for PC people, you may need to install Git if you've not done it before. Git, the code control system, something that I imagine most of you have used, some might not. It comes installed on Macs by default, but not on Windows. And so if you follow this link, you get to the Git download page, you follow the instructions to download, and you then have to say OK about 20 times and just accept the defaults for everything. I just went through and did this myself, and I was pressing OK. So go through all of those things, just take the defaults all the way through, and you will install Git on your computer. And so once you have done that, come back to the repository. The next thing to do is at the top here, there's this green button, code. And if you press that green button, it comes up here with the link to the repository. And you can pick either of these, but we were going to pick this HTTPS one, and we're going to press, actually, you should pick this one, and then press the copy button to copy it to clipboard. What we're now going to do is we're going to go and open a new PowerShell. Let me see, type PowerShell in here. I'm a little bit clumsy at the PC because it has been a little while since I've done this, so you may have to bear with me if I make a fool of myself, but there we go, up comes the PowerShell. And now the first thing you need to do, which you may already have, is create a projects directory, something that where your different projects that you work on will go. You may already have a projects directory, but if I do cd projects, it turns out I do not. So I can make a projects directory by doing this. You may also just use the Windows Explorer, the File Explorer if you prefer. You don't need to use the command prompt, but easy doing that. So I've made a new projects directory in my home directory. I'm now going to cd into it. And here we are in our projects directory, which of course is empty, or dir if you prefer the Windows way. What I now type is very simple. It is git clone, which means I want to make a local copy of this repository, and then you put in the name of the repository, the link to it that we copied a second ago. And when we do that, it will immediately download. It's already happened. All the code has been cloned to my local drive. So if I look here, you'll see that there is indeed a folder called LLM Engineering that we will now go into. And there is all of the code that will be our playground for the next 8 weeks. And now it's worth mentioning that sometimes people use the expression, the project root directory, to mean this folder, LLM Engineering. It is the root directory of this project. So if I ever say verbally, or if it's in the README that it mentions project root, I'm talking about this directory, LLM Engineering. There we are. So the next step is now to install Anaconda, which is, as I say, it's a reasonably heavyweight tool because it's super powerful. And the place to do that is back in the README again. There is a link to where you go to install Anaconda, and there it is. And I have that up over here. Except the cookies. This is the Anaconda documentation for installing on Windows. And it tries to get you to give your email address and various other things, which you can feel free to do if you wish. But then at the end, you can also just say, well, we'll do now, press download. It suggests you could provide an email, but you can also just say skip registration here if you prefer. And then you get to this download now page. And this is the download that we will do. Now, Anaconda is quite large. This is a 5 gigabyte download. And so it may be something which you don't have the room for, and you may also find that this is too heavyweight. And there is the alternative approach using Virtualenv that I will record after this, which is a simpler approach, but it's less guaranteed to be compatible. And, you know, it's less hardcore. If you want to be a hardcore LLM engineer, you should at least try the Anaconda route. So you press the download button, which I already did. It then brings up a screen to install Anaconda, the usual installation wizard thing. And you have to press yes a few times. It does prompt you for where you want it to install. Some people have selected there to install it to a different drive to make sure that you have capacity. And then when that is done, it will complete the installation, take a few minutes to download and install, and you will have the Anaconda program on your computer. And what does that mean? Well, the thing that it means as far as we're concerned is that whilst we have this PowerShell that we are very familiar with, there is also a new thing on our start menu, which is called Anaconda PowerShell. And that, if we open it, looks very similar, looks just like a normal PowerShell, but it is in fact a special Anaconda one. I'll try and expand this window for you. Hold on a second while I fumble. Now what have I done? There we go. I'm hopeless at this. There we go. So the way that you know that it's an Anaconda PowerShell is that this word base appears to the left, which means that we are in a world, a base world, rather than in a world that we have built especially for an environment. All right. So now I'm going to go into our projects folder that we just made, and I'm going to go into LLM Engineering. There it is. So we're now in the project root directory, as I explained is the right term for it. And I'm now going to run a simple command, which is Conda which is the name for running Anaconda commands. Env, which means environment. Create, I want to create a new environment. -f means I'm going to specify a file which describes exactly everything that I need for this environment. And the file is called environment.yaml. And you can see environment.yaml right here. So that is what I'm going to do. Now, at this point, you will need to go and get a coffee, and maybe even 2 coffees. So it does take a bit of time to install this full environment. The first time, so when I do it, it probably takes a few minutes because I've done it before. The very first time, it might take somewhere between 10 minutes and 20 minutes, depending on your internet connection. And that's going to be a thing to look out for. So what's it actually doing? So it's looking at all of the packages that we say that we need for this data science environment. And it then figures out for this particular type of system, whatever chip you've got, and for the various configurations that you've got, what are the compatible versions of every single package that we need to do things like, in the future, we'll have an object database, we'll be using LangChain, we'll be using Gradio, all sorts of things. It makes sure that we pick the latest versions that are all compatible with each other and also compatible with your processor and so on. And that's why it now says solving environment. That's the equation that it's solving with lots of different decisions to make. So it's going to make those decisions, and it's then going to install all of those packages on your computer. I'm gonna keep going with the sentence for a bit longer to see if it's going to get close to wrapping up. Otherwise, I might have to break and come back in just a second. All right, it looks like it's going to take just a couple more minutes. So I'm going to pause the video and I will return when this is ready. Well, it's just as well I didn't hang on in there. It took another 5 minutes from that point to finish. So that would have been an embarrassing amount of 5 minutes of my waffle that I've rescued you from. So anyway, this can take a few minutes, and I've got a fast connection, as I say. So it could well be 20, 30 minutes for you. So hang on in there. But obviously, if it takes unspeakably long, then abandon and go to the next video where we will do it differently. But if it's completed, your Anaconda PowerShell prompt should look something like this. It still says base at the end there. And we've created an environment that is known, it's called LLMs. That's the name I gave it. And to now activate that environment, which means to make that be the live world that Anaconda is working within, you simply type Conda activate LLMs. And you'll need to run that. You'll need to, anytime that you come back to your computer that you want to start everything again, before you get started, you will need to remember to open up an Anaconda prompt and do Conda activate LLMs. And your clue that it is now working is that you'll see LLMs written over here on the left, to the left of my prompt. And that is telling me that I have successfully created my Anaconda environment. And another way we can do it is that if we type Python -- version, it will tell us that the version of Python we're on is 3.11.10, which is the version, well, at least 3.11 is what I specified for this environment. So we know that we're on exactly the same version of Python, and everything should be compatible. And it just remains for me to type these 2 words, Jupyter Lab. And this is going to open up the Jupyter environment, which is this data science environment where we can work really effectively together on code. Again, some of you probably know this back to front. For some people, this might be new. I press enter. It's going to start Jupyter Lab. Up it comes. The first time it might prompt you for which browser do you want to open, but then it opens up with Jupyter Lab on my computer with our 8 weeks that lies ahead of us. And we are good to go. That is the PC instructions. Hopefully this has all gone well for you. If it hasn't, please reach out to me, let me know, and I will get you sorted. I will see you then for the next video. And welcome back to Team PC and Team Mac as we come back together again for a quick video. In this one, I'm just going to quickly walk through what you do if Anaconda has given you problems, you're not able to get that to work, and you want to fall back to the simpler Virtualenv approach. This is a quicker, simpler approach. It's less guaranteed to be compatible. It's less heavyweight and powerful than the Anaconda environment, but it's perfectly okay. And so by all means use this if you would prefer. So I'm going to do it on my Mac, but I'll point out when things are different for the PC, and it's basically the same. Although I'll say the instructions begin where it says alternative setup instructions in the README on the repo. And one important difference between PC and Mac is that if you haven't, I imagine that almost everyone on this has installed Python before on their PC. But if you haven't, then you will need to do that. Python comes on Macs by default, but not on PCs. So I've got a link in here to go to the Python website. When you go to the Python download website, you can choose to download the latest version of Python, but it might be better to choose Python 3.11.9, which is the latest version of 3.11 to be compatible. And you can come down here and do a Windows installer to install on Windows. And if you don't have this version, and if you have the time to install this version on Windows, that would be better. Okay, once you have done that, then on a Mac, bring up a terminal window. On the PC, bring up a normal PowerShell prompt, not the Anaconda prompt, just a regular prompt, and go into the projects directory that we created earlier, and then into the LLM Engineering directory where the project sits. And now you do a simple command. Let's first just quickly check what version of Python we're running. Python -- version. And on my computer, my default version is actually 3.12.3. It still works as far as I can tell for everything, but it's not as guaranteed to be compatible. But still, I'm going to push ahead with this. And what we now do is we type Python -m venv. You might wonder what magic, what strange concoction that is. Python -m venv is saying I want to create a new virtual environment, and then the name of that virtual environment is going to be venv again, which is something that people usually often use. And if I look in this directory, you'll see that there is now a folder called venv virtual environment, which will contain all of the Python files for this virtual environment. And that, so far, everything has been the same with a PC. What I'm going to do now is different between a Mac and a PC. On a Mac, what we're going to do is activate this virtual environment. On a Mac, you do that by typing source venv/bin/activate. And again, all of this is, of course, I just did that. All of this is, of course, written in the README instructions. And the way we know we've activated the environment is that venv appears over here on the left. You can see there's also this base here because I've got Anaconda installed. You may not see that if you haven't installed Anaconda, and on a PC you won't see that. But that can be safely ignored. We are in the venv environment. And now what you do, which is something that probably most of you have done many times before, is we do pip install because we want to install Python packages. -r means we have a file of names of packages that we want to specify, and it's called requirements.txt. And then when I press enter, it is now going to be installing these packages, but it's not installing them on my the Python that comes with my box. It's installing them specifically on this virtual environment called venv. So I'm isolating my environment from anything else that I might be doing on my computer with Python. And you can see that there's plenty going on here as it does all of these things. It will be slower for you because you can see it's saying it's used cached because I've done this before. It won't be cached for you, presumably, so there'll be a lot of downloading going on. But it's still a lot quicker than setting up the Anaconda window. And then the business happens at the end right now. It is at the moment now going ahead and installing all of that. And you can see a lot of different packages here. Of course, only some of these are the packages we're actually going to use on this course. Many of them are things on which they depend. So it's installed both the packages we need and all of their dependencies up there. But you'll see that there's things like SQL Alchemy, and that's because we're going to be using an object database that's going to depend on that. And you can see other things going on here. Chroma is the vector data store, a wonderful open source vector data store that we'll be using. Tokenizers, part of Hugging Face's code. So lots of things. You can take your time while it's doing this to look around and see the names of some of the packages that we will be using. All right, that has now happened, and it didn't take very long at all. And at the end of this, all I have to now do is, again, I might just quickly mention that the command for a PC to activate your environment is in fact, venv and then /scripts /activate. So you would type that first, and then you would type the pip install -r requirements.txt. And of course, that's all specified in the README. But whether you're on a Mac or on a PC, at this point, all you would do is type the simple Jupyter Lab, and with any luck, when I press enter, it is now going to launch the Jupyter Lab environment. Here it comes. And this is going to be our home for the next few weeks, the next 8 weeks, folders for each of the 8 weeks, and the usual setup. The only difference being now we have this venv folder, which contains our virtual environment. So that's the fallback plan. I hope that makes sense. If you have any problems at all with the fallback plan, then please, please, please reach out. I will fix it. We'll get you on your way quickly. All right, on to the next video when we're going to be doing setting up API keys with OpenAI. See you there. Now, I know what you're thinking. We've been building environments for so long. Are we not done yet? We're almost done. We're almost done. There's 2 more steps to go, and then we are through with environment setup and onto projects. So the next thing we have to do is set up our keys to use OpenAI so that we can connect from our Jupyter Lab environment to run with some of the most powerful models on the planet. If you go to the README in our GitHub repository and you scroll down a little bit, we'll get to the point where there are the links to the major providers, and we're just going to be using OpenAI for this week. And if you click on that link, it will take us to the OpenAI page. If you've never been before, you will have to sign up or sign in using Google credentials or creating an account. Now, before we go further, I have to explain something that's pretty confusing, which does sometimes throw people. All of the major closed-sourced providers, like OpenAI and Anthropic for Claude and Google for Gemini, have 2 different types of plan that are completely separate and don't have any relationship with each other. One of them relates to their web tools, the front-end tools which you can use to chat with, like famously ChatGPT that we all know well. ChatGPT has a pro plan that you can pay for if you want to be able to use some of the latest models that we'll look at later, like O1 Preview and GPT-4 with Canvas and others. That needs a pro plan in some cases. And the pro plan costs about $20 a month in the US and similar pricing in other regions. A fixed monthly price, and then you have almost unlimited access to those models. The same is true for Anthropic, same kind of thing, and Google Gemini also. But this is entirely separate to the API world. The API world is where you can call out to the model directly using code, and it's running on the cloud, and it will respond with answers to your questions. It's a different type of pricing plan. There's no monthly subscription. There's no payment whatsoever monthly, but you do have to pay per API request. It's a pay per request situation. And the payment per request, we'll talk more detail about API costs later, but it's really tiny for any project that we work on in this course. For most of the projects, except where I will mention otherwise, it is a fraction of a cent. It is tiny. So there is really no harm in trying out some of these APIs, and it gets you such power, gives you access to such incredible models. Even though some of the models we'll use that are open source are very powerful, these frontier closed source models are super powerful, as you will see. And so it makes sense that you have to pay a small amount for the compute that goes behind the processing to generate these responses. But having said that, there is a hitch. There is something about this pricing which is in some cases it's new, and it may be different in different regions. But certainly for me and for OpenAI, they have a minimum that you have to put down to use the API. And in my case right now, it is a $5 minimum. So you have to put in at least $5. And then as you use the API, you'll start to charge down against that $5. We're going to use a fraction of that in this entire course. But there'll be plenty of other ways that you can use that $5. I assure you, there are so many projects we'll build. There'll be so many exercises for you for real useful things, ways that you'll be able to spend that and have a good outcome from it. So my sales pitch to you would be that it is well worth it. I would do it, but it is, of course, a personal choice. If you don't feel comfortable putting down the $5 or you'd rather not, that's fine. You can watch me as I go through the exercises. And what I'll do is I'll show you a way that you can use open source models instead. We'll be able to use Ollama, the thing that we did at the very, very start, and you'll be able to use that as an alternative to using a frontier model. Now, the results, of course, are not going to be the same. The Ollama models will be using as like a 2 billion parameter model compared to GPT-4o that is rumored to be about 10 trillion parameters, perhaps like 10,000 times as many. So it is a different quality of model, but you would have to put down that $5 up front. So that's the decision for you. And again, my take is that it is worth it. So in order to do this, though, what you need to do is once you've come into the OpenAI platform, you've logged in, you've got to this point, there's just two things you have to do. You first have to go to the settings button up here. And on settings, over here, you go to billing. And on billing, this is where you need to have some credit balance to be able to use the GPT-4o. And the minimum that it will take is $5. You have to press add to credit balance and then punch in a credit card and it will take $5. And keep auto recharge off. You don't want them snapping from your card without your permission. As I say, this has been, I use it all the time and I barely manage to get beyond a few cents a day because we use the GPT-4o mini, the cheap version, almost exclusively on this project, on this course. So this $5 is more than enough and you'll be able to put it to fine use, I assure you. So if you are comfortable doing this, then go ahead, go to billing, put on your $5. And then the next thing is to go to dashboard over here. And then down to API keys here. And then you have to come here and press this create new secret key button right here. You have it set to you. You can give it a name if you wish. You give permissions all, and then you press the create secret key button. And when you do that, it's going to show you a new secret key that you will have created. And it will give you a chance to copy that secret key into your clipboard. And you need to do that because it won't let you ever see it again. This is the most you'll ever see of that secret key again. It is your secret and you have to copy it and keep it somewhere safe. We will use it in just a second. Once you've done that, we'll be ready to actually put this key to use, and we are almost there. We are almost done. So with any luck, you have now got a secret key copied. You've forked out $5 or local currency equivalent, and you're ready to go. And I will see you in the next video for the very final step of setting up our environment. We're on the home stretch. This is the final step in the environment setup, and it's an easy one. It's one that's easy to make mistakes as well, but I'm going to guide you through it, and there'll be no problems whatsoever. I'm going to show it to you both on a Mac and a PC, all in one video, so you guys can see how it works for both. And it's pretty simple. It's called creating a .env file, which is a common way to store secrets in a way that you can access in your project that don't get checked into source code control, doesn't go into Git, which means that your secrets are safe. We're going to start with a Mac. Here I am. I am going to go into my projects folder that we set up, into LLM Engineering. So we are now in the project root directory, as they say. And what I'm going to do is create a file called .env. And the way that you create a file from the way you bring up an editor in here is you can use Nano, which is a very popular tool. And the name of our file, the thing we're going to create, is going to be called .env, literally a period and then the letters EMV. Now here's the thing. This is a fussy step. The name of the file must be exactly .env. It can't be like mykeys.env or ed.env, and it can't be .env.text or anything like that. It's got to be exactly .env. Otherwise, it doesn't find it. So that's the rule. Now that I've done that, up comes a new empty file called .env. And what I'm going to put in here is very simple. And of course, this is all laid out in the README, but I'm going to put in this file just OpenAI underscore API underscore key equals. And now I put in here the key itself that I have hopefully stored very safely from the last video. And it begins sk-proj- blah, blah. Put that in the file and don't have a space before the equal sign or after the equal sign. And there's one other like really unpleasant gotcha. If you use the notebook on the notes application on Mac, I use that a lot. Sometimes if you paste something in there and then press enter and copy it out, it replaces hyphens with long dashes if you're not careful. So just make sure that whatever, if you haven't copied it straight from that website, that nothing has got mangled in your key. That was a really hard problem that it took me a while to track down that one student had. But maybe it's just a rare situation that happens. But anyways, if you've been careful, we've got the key just like this. You've got the full key laid out there. And then you press, as it says on the bottom of the screen on a Mac, Command O or Control O to save, and X gets out of it. Now, there's one thing to look out for. If I do an ls, you'll see that there isn't a .env file here, and you'll also not see one when we look in Jupyter Lab. And the reason is because any file that begins with a dot, a Mac considers to be a hidden file, a secret file. And if you want to see that, you'd have to do ls-a, and then you see all of the hidden files, and you'll now see included on the bottom left there is .env. And if I want to see what contents that has, you'll see that it has the OpenAI API key. And of course, in your case, hopefully you have a full key in there. So that's it. That's the Mac version. Let's look on a PC. Let me flip over to my emulator of PCs over here. Here we have it. So on a PC, the thing to use is the program called Notepad, and you can press the Windows and R to run, and then type Notepad and press OK, and up comes Notepad. In this Notepad, we say OpenAI underscore API underscore key equals, and then you paste in your key, which should start sk-proj- blah, 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 blah. That should go in here. And then you go File, and you go Save As. Now, you then will have to navigate around to find your way to the LLM Engineering folder, which I've already got set up right here. And now there's like a little gotcha here, a little trick. You have to know where it says Save As Type. You have to change that to be all files. And now in here, you can type .env. And I will save this right now. And that should be done. Exit. And now back over here, if I do an ls, we do see that there is a .env and it doesn't have any nasty name to it. So that has been created successfully. And that is the final step. We are now finally ready to actually go and do a lab. Congratulations. Congratulations. I guess I should hold the congratulations until you see it working in the lab, but tentative congratulations on getting it this far. And I can't wait to see you for the next video when we're actually going to do something. See you there. It feels like 100 videos ago that I told you that we were going to have instant gratification with our first project. And you'd be within your rights to feel like it hasn't exactly been instant gratification, but never fear, I'm going to make up for it with a nice, juicy project to start us off. So if you already have Jupyter Lab running, like the window up in your browser, please close that. And if you already had your Anaconda prompt in Windows, then exit out of that and close that and start again. Bring up a fresh Anaconda prompt in a PC, and on a Mac, bring up a fresh terminal, having closed everything down because we've made that .env file and I want to start from absolute scratch. Go into your projects folder into LLM Engineering, and you'll remember the first thing, and you'll always have to do this if you come in fresh without your Jupyter Lab running, you type Conda activate LLMs. That is how you activate your environment. If you're using Virtualenv, then there was a different PC and a Mac way of doing it in the README. I do that, and my clue is that the prompt has now changed to LLMs, and for Windows people in your Anaconda prompt, it should have done the same thing. And now you type the two wonderful words Jupyter Lab. And when you do that, it thinks for a second, and up comes Jupyter Lab right here. Instant gratification, it says. So You may not see this actually. It may come up for you the first time just looking like this, perhaps. This might be more similar to what you're seeing right now. So this is Jupyter Lab. For some people, this is old news. You've probably used this a lot. For some of you, this might be new, and I'm here to tell you that it is fabulous. It is this very interactive way for data scientists to work with code. It's full of some hairy stuff, like use global variables a lot in Jupyter Lab. And we know, as if you're from an engineering background, that that's not very good behavior, but it's something that we do as part of research and development. And so we just do it. As you will see, it means that you can be very productive as you experiment. When we get to week 8 at the end of the course, we're going to be looking at productionizing the stuff that we do. And we'll be talking about how we migrate from Jupyter Lab into proper code and deployment and so on. But we don't need to worry about that stuff now. So on the left here, you have something called the file browser, which is kind of what you would expect. Actually, you might have come in like this, of course, which is showing you the parent directory. There's a directory for each of the weeks that we'll be going through, and you can see the things we know about. The README and the environment.yaml are here as well. And without further ado, we're going to go into week 1. Now, if this is your first time ever in Jupyter Lab, I've made a guide to Jupyter Lab that you can come into and look at. You just double click here and it will bring it up and it will take you on a quick tour of what you need to do, just so that you get a handle of things. For example, you'll learn that you can click in one of these boxes here, which is called a cell. You hold down Shift, you press Return or Enter on your keyboard, and it executes it and prints the results for. And as you go through, you scroll down and you go on to do the next thing, and you can just come in and execute and see my favorite fruit is bananas. And you can go through and use this guide to Jupyter as a way to learn some of the tricks of using Jupyter Lab. And I hope that will be helpful for you. But I imagine many of the people on this course will have used Jupyter once or twice and will be familiar with the wonder of it. And so that brings us to our day 1 project, which is right here. And again, I've slightly cheekily called it instant gratification. I know you've put in a fair amount of work for this, and day 1 has been a pretty long day, but it hopefully will be worth it. There's some spiel here to remind you one more time that I'm here to help. There's my email address. This is my LinkedIn. I always love it if people connect with me on LinkedIn. It's nice if you put a message there to say hi, but you really don't need to as well. If you just want to connect, that's good with me. I always will accept connections from people taking this course, of course. The other thing it tells you right here is that there is another notebook. These Jupyter Labs are known as notebooks. People call them for historical reasons. There's another notebook here called Troubleshooting. And troubleshooting is where you will go if you have any problems. Troubleshooting over here begins, oh dear, has step-by-step to go through and figure out exactly what's going wrong. I check your M file looks good. I check everything as we go through it. So if any troubles at all, you go to troubleshooting and we'll have it sorted. But otherwise, we're starting with the day 1 notebook. Generally, during this course, we'll have a separate notebook for each day so that you can go through and learn from that day and do the exercises. Okay, so the first thing we start with is some imports. I often like to put the imports at the top. You have to execute the code in Jupyter Lab from the top downwards, and we'll start by clicking in this import cell, hold down Shift, press Return, and that runs. If this gives you an error, then head over to the troubleshooting notebook. I'll tell you what's probably happening, what's going on, and what you need to do about it. Most likely is that for some reason the Conda environment isn't activated, and I'll tell you what to do about that. Okay, the next thing we're going to do is connect to OpenAI. So this is where we are going to make our connection to the OpenAI API service so that we can make a call to GPT, the frontier model, and ask it questions. Now, of course, we're going to be talking a lot more about OpenAI and GPT and what all these things mean. The idea is to get a flavor for it right now. This is just our first lab. So the first thing we do is call something called load.env, and that looks at the .env file and loads in our secrets. Right now we have one secret, the OpenAI API key, and we're going to load that in and put it in a variable called API key, and we're going to check that it looks decent. It says API key found and looks good so far. If it doesn't say that, if it doesn't say API key found and looks good so far, head over to troubleshooting. We'll sort it out. Or email me, LinkedIn with me. We'll fix it. Okay, the next thing we do is this simple thing here. We take OpenAI, we create an instance of it and put it in OpenAI. This is where we're actually making the connection to OpenAI. Done. All right. So what is this project going to be about today? What business problem are we actually going to solve? It's going to be really simple and actually quite cool. We're going to write a program which is going to be able to look at any web page on the internet, scrape the contents of the web page, and then summarize it and present back a short summary of that web page. You can think of it like you're building your own little web browser, which is like a summarizing web browser. If you know the Reader's Digest, it's like a Reader's Digest web browser. That's what we're going to do. That's going to be the project. And we're going to start by defining a class website, which is going to be a very simple utility class that will represent a website that we've scraped. It's going to be a class which will have a URL, a title, and a text. I'm not going to go through this in line by line because you'll be able to read this yourself and get a sense for it as you come through and execute this right after this. And we'll have other labs where we'll go into much more detail on what's going on. This is just about your first experience with it. Now, in this, in the constructor and where I set up this class, I use a package called Beautiful Soup, which, again, I imagine many of you have come across at some point. It's a fabulous little package that's used for parsing web pages, and people who do web scraping on a regular basis, like myself, know Beautiful Soup very well indeed. And you can use Beautiful Soup to do things like pluck out the title of a web page and get rid of things like scripts and style and images and inputs from a web page, and then figure out its text. So that is what we're going to do with our class website. And then what we're going to do finally is try one out. So we're going to create a new website object, and I'm going to pass in this particular website for a thoroughly undesirable website. Happens to be my website. And it's a very vanilla website. But we'll create a class to represent it. We'll look at its title and look at the text on the website. Let's see if this works. Yes, it works. And here we go. We're seeing the name of the website, and there is something about what's going on that website right there. This is just the contents looking a bit scrappy because it's, of course, the contents of that web page with images, JavaScript, style sheets all removed. Okay, so far we've not done anything to do with generative AI or LLMs. That's coming right up, and we're going to get to it in the next video. It's time for our first LLM experiment at this point. So, some of this you may know well, you may know very well already. For some people this might be new, but let me just explain. The models that we're going to be using, these frontier models, have been trained in a particular way that means that they expect two different types of instruction from us, the user. One of them is known as the system prompt, and one of them is known as the user prompt. The system prompt is something which explains the context of this conversation. It tells them what kind of task they're performing, what tone they should use. And we'll be experimenting with what it means to change a system prompt and what kind of information that you can include in the system prompt throughout this course. The user prompt is the actual conversation itself. And in our case right now, it's going to just be the conversation starter. And the role of the LLM, of the large language model, is to figure out what is the most likely way that it should respond given this user prompt. If it's given this user prompt and in the context of this system prompt, what is the most likely next text that would come after it, that would come from an assistant responding to this user? So that's the difference between the system prompt that sets the context, the user prompt that is the conversation starter. So we're going to set a system prompt, and this is what it's going to say. It's going to say, you're an assistant that analyzes the contents of a website and provides a short summary, ignoring text that might be navigation related. Respond in Markdown. You'll see more what that means in just a second. So that is our system prompt. For the user prompt, it's going to take we're going to write a function, user prompt for, and it's going to take a website as the argument to the function. And it's going to say, you are looking at a website titled, name of the website. The contents of this website is as follows. Please provide a short summary of the website in Markdown. If it includes news or announcements, summarize these too. And we then take the text from the website object that Beautiful Soup plucked out for us, and we add that into the user prompt, and we return that user prompt. So let's just quickly, let's run that cell right now, and let's just have a look now. So after doing that, if I just look at what system prompt has, it has that text, of course, that we just said. And now if you remember earlier on, we created a new website object and we stored it in this variable ed. So if I come here, I should be able to say user prompt for, and then pass in the object ed. And what we'll get is a prompt. It might be easier if I print this so that it prints out empty lines. And here is the user prompt string that we've created. It says, you're looking at a website titled blah, blah, blah. The contents of this website is as follows. Please provide a short summary. Look, it looks like we should have a space right here. Otherwise, it might be confusing. Let's try that again. That's always why it's worth printing things as you go, because you'll spot little inconsistencies like that. I think it'll be nicer, actually, now that I look at that, if we have a carriage return there, like so. Let's have a look at this prompt now. You're looking at the website, and there we go on a separate line. That looks good. Okay, so let's talk about the messages object. So OpenAI expects to receive a conversation in a particular format. It's a format that OpenAI came up with and they use for their APIs. And it became so well used that all of the other major frontier models decided to adopt the same convention. So this has gone from being originally OpenAI's way of using the API to being something of a standard across many different models to use this approach. And here's how it works. When you're trying to describe a conversation, you describe it using a list, a Python list of dictionaries. So it's a list where each element in the list is a dictionary. And that dictionary looks like this. It's a dictionary with two elements. One of them has a key of role, and here the value is either system or user. A key of role, and the value is system. A key of content, and the value is, of course, the system message. There's another dictionary where there's a key of role. The value is user, because it's the user message, the user prompt. Content is where the user message goes. User message and user prompt are the same thing. So hopefully I didn't explain it very well, but it makes sense when you see it visually like this. It's just a dictionary which has role and content, system and system message, user and the user message. And there are some other roles as well, but we're going to get to them in good time. This is all we need for now. So this is how messages are built. And if you look at this next function, def messages for, hopefully it's super clear to you that this here is creating exactly this construct using code. It's going to put in there the generic system prompt we came up with, and it's going to create the user prompt for the website. So let's run that. And now presumably it's clear that if I say messages for ed, which is the object for my website, let's print it so that we see empty lines and stuff. Actually, sorry, in this case, it might be better if we don't print it. If we just do this, it might look a bit clearer. There we go. And now you can see that it is, it's a list of two things, role system, and there's a system message, role user, and there is the user message. Okay. It's time to bring this together. It's time to actually do it. The API for OpenAI to make a call to a frontier model to do this for us is super simple. And we're going to be using this API all the time. So whereas now it might look like it's a few things to remember, you're going to get so used to this. But we're going to make a function called summarize. And that's going to do the business. That's going to solve our problem and summarize a URL that's passed in. It will first create a website for that URL, just like we did for Ed. And this is where we call OpenAI. We say OpenAI, which is the OpenAI object we created, OpenAI.chat.completions.create. And that, for now, you can just learn it by rote. We'll understand a lot more about that later. But as far as OpenAI is concerned, this is known as the completions API because we're asking it to complete this conversation, predict what would be most likely to come next. We pass in the name of the model we're going to use. We're going to use a model called GPT-4o Mini that you'll get very familiar with. It is the light, cheap version of GPT-4o, the one of the finest models on the planet. This will cost fractions of a cent to use this. You pass in the model, and then you pass in the messages. And the messages we pass in use this structure that we've just created. And that is all it takes. What comes back, we put in this object response. And when we get back the response, we call response.choices0.message.content. Now, I'm going to explain what this is another day. We don't need to know for now. We just need to know that we're going to do response.choices0.message.content. That's going to be it. That is our summarize function. And with that, let's try summarizing my website. We're running, it's now connecting to OpenAI in the cloud, it's making the call, and back here is a summary of my website. We have just spent a fraction of a cent, and we have just summarized my website. We can do a little bit better because we can print this in a nice style. GPT-4o we've asked to respond in Markdown, and that means that it's responded with various characters to represent headings, things in bold, and so on. And we can use a feature of Jupyter Labs that we can ask it to actually show that in a nice Markdown format. So let's do that. Let's use this display summary function and try again. Again, we're going to GPT-4o Mini in the cloud. And here is a summary of my website. It says something about me. It's very nicely formatted, very nicely structured, pretty impressive. And apparently it highlights my work with proprietary LLMs, offers resources related to AI and LLMs, showcasing his commitment to advancing knowledge in this field. Good for you, GPT-4o Mini. That's a very nice summary. Okay, and now we can try some more websites. Let's try summarizing CNN.com. We'll see what this happens. Obviously, CNN is a much bigger result you've got here. We get some information about what's going on. I'm actually recording this right now on the 5th of November in the evening, which is the date of the 2024 elections going on right now. So that, of course, is featured on CNN's webpage. We can also summarize Anthropic, which is the website for Claude, and they have a nice page. And here you go. And you can read more about it in this nice little summary of their webpage. All right, and that wraps up our first instant gratification. It's juicy. It's something where we've actually done something useful. We've scraped the web. We've summarized. Summarization is one of the most common Gen AI use cases. So common, it's useful for all sorts of purposes. We'll be doing it a few different ways during this course. Even in our week 8 Agentic AI solution, we'll be using something that will do some summarization. So it's a great thing to have experimented with already. So there are so many other business applications of summarization. This is something you should be able to put to good use. You should be able to think of some ways you could apply this to your day job right away, or be building a couple of example projects in GitHub that show summarization in action. You could apply it to summarizing the news, summarizing financial performance from a financial report, a resume and a cover letter. You could take a resume and generate a cover letter. There are so many different things you can do with summarization of documents, and also adding on to that, the scraping the web angle of it. So have a think about how you would apply summarization to your business and try extending this to do some summarization. There's also for the more technically inclined, one of the things that you'll discover quite quickly when you use this is that there are many websites that cannot be summarized with this approach. And that's because they use JavaScript to render the web page, and our rather simplistic approach has just taken just made the requests the server call and taken what we get back. But there's a solution, and the solution is to use a platform like Selenium or others like it, or Playwright, which would allow you to render the page and do it that way. So if you're technically inclined and have some background with that kind of thing, then a really interesting challenge is to turn this into something that's a bit beefier and add Selenium to the mix. As it happens, someone has already done that, one of the students, thank you very much. And if you go into this folder, Community Contributions, you'll see a few different solutions, and one of them is a Selenium-based solution. So you can always go in and just look at that yourself, or you can have a shot at doing it too, and you'll find the solution in there. And if you do come up with a solution to that or to anything, I would love it if you were willing to share your code so that others can benefit from it. Ideally, put it in the community contributions folder and be sure to clear the output. So you go to kernel, restart kernel, and clear outputs of all cells. Otherwise, everything that you've got in your output would also get checked into code, which would just clutter things up a bit. So do that, and then if you could submit a PR, a pull request, I can then merge that into the code. And if that's a new thing for you, it is a bit of a process. There is a write-up here for exactly what you need to do to make that work. Anyways, this was the first project, the first of many. It's a simple project, but it's an important one, a very important business use case. I hope you found it worthwhile. I will see you for the next video when we wrap up week 1, day 1. So I realized that day 1 of week 1 has been a pretty long day, and I assure you that the other, generally speaking, the other days won't be as long. We had some foundational work to do to get the environments up and running, and hopefully that you're happy that we've got there and you're feeling satisfied that we ran our first big project. As a quick recap of what we got done at the very beginning, seems like an age ago, we used Ollama to run LLMs, open source LLMs, locally on your box, running them to generate content. Then we set up the environment, and then we used OpenAI in the cloud to make a call to frontier models, to GPT-4o Mini was the model we used to generate text there. And obviously we're using here a closed-sourced model that is maybe 1,000, 10,000 times larger. We pay a small price for that in the form of a fraction of a cent, but we do have to pay to use that. But what we get back is much richer in quality than using a small local one. We learned how to distinguish between a system prompt and a user prompt, just at a high level. We'll do a lot more on that, of course, in the coming days. System prompt setting the tone, the context of the conversation. The user prompt, which is the conversation itself. We used it for the opener. Later, we'll be using it for many rounds of conversation. And then most importantly, we applied this to the field of summarization, and a critical use case that comes up so many times. It's applicable to many different problems. It's something that I hope you'll find ways to use this in your day job, in what you do already. And if not, then certainly you should be able to find personal projects that you could come up with where you could apply this. And I'm really excited to see what people come up with. So that's what we got done. And would you believe we were already 2.5% through the course, on the way to being an LLM engineering expert. So it's already, progress has been made. Tomorrow, we're going to talk about what really is that journey, like what are the steps, so you have a clear sense of what's to be done, set you up for success, and then we'll do some content. We'll talk about what are the leading frontier models and the different ways to use them, and we'll also do some quick lab work, something I promised you, that people who would prefer not to fork out dollars to OpenAI, I'm going to show you how we could use Ollama as an alternative with the same code that we just wrote, calling Ollama running locally instead of calling out to the frontier model on the cloud. So we'll do that tomorrow too. Very much looking forward to it, and I will see you then.